Hi, teacher. I arrived earlier because I couldn't really figure something out.
Oh, what's that?
Well, we kind of learned about the periodic table as well as the structure of an atom in the previous lesson, right?
That's right.
But how do we combine both concepts together? Like, how does the periodic table inform us about the structure of atoms in various elements?
Well, let's do a recap, and then we'll look into that, okay?
Sure. Let me start with what I remember.
All right.
Okay. I recall that the core of an atom is called the nucleus. The electrons moves around the nucleus like planets orbiting the sun.
That's right.
But teacher, here's where the confusion comes. How do we know how to arrange the electrons in an atom based on the periodic table?
Oh, don't worry. Let me explain. Take carbon as an example. Carbon's atomic number is 6. Let's count to 6 on the periodic table. We count 1, 2 on the first period. Then 3, 4, 5, 6 on the second period. This means that there are 2 electrons on the first electron shell and 4 electrons on the second electron shell.
I think I understand. Well, let me try to count for oxygen. For oxygen, I have 1, 2 on the first period and 3, 4, 5, 6, 7, 8 on the second period. That means there are 2 electrons on the first electron shell and 6 electrons on the second electron shell for oxygen.
Very good.
And those 6 electrons on the second electron shell of oxygen are called outer shell electrons or outer electrons because they are located in the outermost electron shell.
That's right! And all these electrons orbit the nucleus, just like planets orbiting the sun.
With the sun similar to the nucleus.
Yes!
But why? Why do the electrons orbit the nucleus and not the other way around?
Well, let's use the solar system analogy. The sun is so massive, and so it attracts all the planets toward the center of the solar system. The mass of the Earth plus all the other planets together are almost nothing compared to the mass of the sun.
And that's why the sun attracts all the planets to orbit around it and not the other way around.
Yes, that's right.
I see. Then the mass of the nucleus must also be a lot greater compared to the mass of the electrons.
Yes, the nucleus is actually thousands of times more massive than the electrons.
Wow, I didn't know the nucleus is that massive.
Well, Fedi, one proton alone is about 1,840 times the mass of an electron, and the neutron has about the same mass as a proton. Since the nucleus is made up of both protons and neutrons, so you can imagine how massive it is compared to electrons, right?